Is by Ben Zorn, and the title on the schedule that you have is not correct. Somebody invented that in lieu of a real title, but I think so. What Ben's going to talk about is his thoughts on the future of runtime systems. And Ben manages a group at Microsoft working on a number of performance and software reliability issues. So I think this would be a good source to hear these thoughts.
Thanks, Vikram.
And we should specially compliment Ben on his new shirt.
It's not representative of our the last minute. This represents the fact that my luggage is still not here. It's all ever-going saga. You'll be appreciate that fact after that long flight.
We got it.
Anyway, so I'm going to be talking about some of my thoughts on future runtime systems. I want to hopefully motivate some of the work we're doing at Microsoft, in Microsoft Research at least, and stir up some controversy here. Okay, so let's get right to the real problem that we're trying to solve. This is a device. It's called it's a nanomedical device. You've heard of such things. It's been proposed by a guy, Robert Freitas. It's called a respirocyte, and essentially it replaces red blood cells. It does the function of the human red blood cell, but it does it mechanically. And he's designed this thing. He's proposed it. Of course, there's some missing details, but specifically, people that think about nanotechnology think of what they call a post-biological era. And by that, essentially, they're talking about replacing things that are now biological with engineered structures that accomplish the same goal, but presumably much more efficiently. So for example, you think about a computer, it can do a lot of things a human brain can do much more efficiently than the chemical process in the brain. Well, similarly, this respirocyte can actually do the things, propose to do the things that a blood cell can do, but a lot more efficiently. In fact, he computes about 236 times more efficient than a human red blood cell. So if you had these in your body, you replace some of your red blood cells with these, you could do superhuman feats. You could win any Olympic running record. You could spend 4 days underwater without breathing, things like this. Okay, so this is the future of computing, believe it or not. But one thing he sort of puts in there, casually, is this notion of nanocomputer. So it's this thing doesn't work without some kind of software running it. In fact, we have to think about this problem very hard because people that are on that side of the world that are designing things, they think of the software as a black box. Somehow somebody's going to program this thing. It's going to do exactly what we want. We're just going to build the structures, and we're going to rely on that software to do what we want. And there's some very important questions that come up with that. What language are you going to use to program this device? Okay, who's going to put it in their body if it's programmed, say, in C, for example? Okay, think about that. When will managed language, and this is really a theme of the whole talk, when will managed languages be just the language that every single program is written? There's no doubt that you would use a type-safe language instead of a language that didn't have type safety and some kind of other managed aspects. And finally, I think you should really think carefully about this question. What fraction of all the future applications of computing, not the ones we think of now, but these nanotechnology applications, for example, are going to be in the realm of the very high dependability. Applications where if they fail, people die. Okay, is it a tiny fraction of all the possible computing uses that people use, or is it a large part of the total? So this is my position. I'm going to put a stake in the ground here. I believe that the pace of technological innovation is actually gated by the quality of the software infrastructure. In other words, if we don't solve the problems that we're talking about today with managed runtimes, basically make them usable by every programmer in every circumstance, then that's going to have a huge impact on the pace of technology innovation. And in fact, no one's going to be building these respirocytes, these nanomedical devices, because if they fail, people will die, and so people will stop building them. So that's one of my stakes in the ground. The other is that I think this is the most important technology focus of our time. I think that just now we're starting to realize that the cost of software that isn't reliable, isn't dependable, whatever, is so high. We've come so far so fast with software, but now we're starting to realize that the cost of this infrastructure, especially when it fails, is extremely high. And if we don't solve this problem, and we don't solve it soon, all this great growth and sort of technology change that we've seen will actually slow down because we'll have to solve that problem. It's going to become a limiting factor. Yeah, Dave. All right, let's make this interactive.
Outside of Microsoft, this is not news.
Do you believe it? Anyway, so this is my perspective. Maybe it's not controversial, but the whole point of the talk is to motivate what we need to do to get there. Okay. So there's a lot of terminology that flies around. Workshops called the virtual execution environment, VMs. People talk about VMs, runtime systems. I have a historical name for it. I'm going to use MRE. It's easier to say in this particular context. And what I mean by managed runtime environment? Well, so I'll be specific. I think of it as it's a delivery format. Some people think, well, it's the IL, right? It's the delivery format. But in fact, that's a combination of the language to express computation, but also all the metadata that comes with it. And in fact, the metadata, all that stuff that tells you about the types and the security model, et cetera, is probably the most important part of managed systems. Is what metadata is there? What do people do with it? Okay, and along with this delivery format, of course, there are things that are assumed. System services like reflection or GC, et cetera, threading, and then finally libraries, base class libraries, some kind of built-in assumed functionality. Okay, so those things together, in my picture, constitute the MRE. So this is an outline of the talk. I'll talk very briefly about some of the history, the evolution, and talk about how we got to where we are. I'll talk about some specific experiences that we've had at Microsoft with building applications in a managed runtime. And then finally, I'll motivate some of the things that I feel we need to do, we really need to focus on in the next 5 years, actually very soon, to handle these problems like the Respirosite. Okay, so one of the important things to think about here is that these systems have evolved rapidly. And they've evolved to the point where they're very large and complex. So for example, they've assumed a lot more dynamism. The software environments that we execute code in are extremely dynamic, all kinds of code flying in from different places. So there's a notion of the internet introduced a whole new source of the things that could be injected dynamically into runtimes. At the same time, you've got this productivity enhancement. You've got this ability for people to specify things at a very high level, talk about very high level abstraction, and have all the details kind of hidden and done under the covers. So for example, Visual Basic, the notion of controls, dropping controls into a visual palette. Extremely valuable to a lot of developers, and saves tons of time. And of course, bookkeeping, we all know that garbage collection makes it a lot easier to write code. Of course, at the same time, and this is most recently in the last 5 years, we've seen a huge emphasis on security and privacy. Okay, how do these systems add to that? Well, we have to have mechanisms in the runtime that give us ways to express things. And so, the JVM, the CLR, both have mechanisms for that. But each one of these pieces adds to the functionality, adds to the complexity of the system, and to the point where we have very large, complex systems. Of course, then there's integration from the language into the language level, things like threads, et cetera. So what does that mean? Well, first of all, there's a big question that we have to answer, and I think this is a great place to start asking the question is, what is the overlap now with the runtime system and the operating system? How much functionality is just historically duplicated in these two bodies? And why? Does it need to be duplicated that way? Are there boundaries that we should explicitly say, well, this is obviously the OS, this is obviously the runtime. The way it is right now, the runtime is basically just taking over. More and more of the functionality is moving up into the runtime. And you can ask yourself, well, what is that OS doing? Okay, another thing that you can look at is very clear is that metadata, the thing I said was the most important, that's actually getting bigger and bigger. And why is that? It's because it gives you information that you didn't used to have. It allows you to do the checking at runtime in these dynamic environments to say, yeah, these types really do match. This interface is what I expected it to be. This guy who just sent something over to me, I trust him because of some reason. And all that metadata, has to be there, has to add, gives us the functionality we want, but it comes at a cost, and I'll talk more about that. People have talked about reflection already. Finally, there's the goal of moving these runtimes into new domains. We've had a lot of success in the current uses of Java and C# and CLR, but in fact, there's a lot of domains where we're just starting to really understand whether or not we can use these languages. And I would offer that many people would say, no, there's lots and lots of types of programs you wouldn't even think twice. I mean, you would never think about using Java or C# for. Okay, so I did a practice talk for this. People said, be more positive, be more positive. Okay, so this is my positive slide. We give ourselves a pat on the back here. Commercial runtimes, a huge success. I mean, you think about all the ways in which Java has changed people's lives. You think about the way in which these runtimes make it easier to write new programs, faster, more effective. Obviously productivity. People have already gone over some of these things. Detecting more errors. Just finding errors is a huge win. And of course, there are performance challenges that have been overcome. A lot of great work being done on optimization, dynamic compilation. A lot of real steps forward. But I would argue that there's still a lot of things that remain here. We have not